places like, okay, let me use a local example like remove.
Just a moment as I do something here. Okay. Once again, Dan, could you kindly confirm if you can see my screen, and what you need to see is the well-architected AWS. Can you see it?
Yes, James, we can see it.
Amazing. Thank you for that. So today, ladies and gentlemen, I'm going to cover a topic which is not new to you, definitely. It's around the AWS architect and the ecosystem. So maybe a bit of introductions. Dan has already mentioned my name. I'm James Juma. I'm currently working as an AWS solutions architect at a company called Silicon Overdrive. In my main work or responsibility is just helping people, clients, customers in their cloud migration journey, be it migrating from one cloud provider to AWS or from on-premise to AWS. So that is what I do. And away from that, I'm also a co-founder of a community called Resource Cloud Academy. This is a community made up of young tech enthusiasts who will wish to start or advance their career also in cloud. And it's an honor to be with you guys, joining you from Nairobi, Kenya. I see I got my friends here who have joined too, and just to say thank you to the AWS Kigali user group for allowing me to do this presentation. Now, without wasting much time, let me delve into our main topic of the day. And if you got any question, kindly you can use the chat box. Then you can inform me of any burning question, or if not, we can answer all at the end of this session. So without further ado, ladies and gentlemen, here we start. Now, well architected. So first, let's start with understanding what well-architected framework is. And basically, when you hear this word, there are two major sections that comes in handy. We have the pillars, there are 6 of them, and the designing principles. So I want to make this session open and interactive. And so without maybe before going to the next slide, I just want one of you guys to unmute and tell me what do they understand by the term well-architected framework. You don't need to give a perfect answer. Remember, we're here to learn, we're here to grow. Any answer is acceptable. So any courageous person to kindly unmute and tell us what well-architected framework is. Anyone? Sorry, I can't see the Zoom because I'm sharing the screen. So if you're there, kindly unmute. Remember, it's not perfect. Just what comes to your mind when you hear the word well-architected framework.
Right.
Yeah. Oh, wait, someone.
Awesome. Go ahead.
Okay. What comes to my mind when you talk about well-architected framework? These are set of guidelines, rules, or design principles that are there to help people who use cloud so that they can build their cloud infrastructure following the best practices. So,
Awesome. That is amazing. Thank you, Albert. Any other trial?
Yeah, I wanted to say that I think a word that comes in my mind when I hear the well-architected framework is security. So having a secure infrastructure. Yeah, I would say that.
Yeah, that is Cynthia. Thank you so much for that. As we go on, we'll definitely have a discussion around security. So both Albert and Cynthia, you are right in your definition. So maybe on my side, I just came up with what I'm going to read now. So the AWS well-architected framework, as Albert put it, it's just a set of procedures and guidelines that helps to make decision when it comes to building system on AWS. So this framework, it's a sort of a dictionary that, you know, AWS engineers, be it solutions architect, be it DevOps engineers, be it cloud engineers use to come up with while designing and implementing workloads on AWS. And as I mentioned, there are two major sections that you're going to cover. We have the pillars and the designing principles. Now, another question before we move on. When you talk of pillars, kindly let's start with the number. How many pillars are there when it comes to the well-architected framework? Any guess?
I think I
5
would say
pillars.
6 pillars.
Nice. I've had 5 and I've had 6. Thank you, thank you, thank you. So that's right. Initially, we had 5 pillars of the well-architected framework, but now there's an additional pillar that was added just a few years ago, which makes the pillars to be 6 of them. We're going to have a discussion around the 5 pillars and probably not into details the 6th pillar. So why will I want to apply the well-architected framework? Okay, so the main reason as to why we need this framework, as I mentioned earlier, it's a sort of a dictionary. It's a guideline, a set of rules and principles that govern how one should deploy the resources on cloud. So if you want to build and deploy fast with lower or minimum risk and make informed decision, we'll definitely have to have a look at this framework, the rules, the procedures, and the guidelines, so that at the end of the day, you make a solution that it's reliable, secure, and highly performing. So that's just a few reasons why you will want to apply the AWS well-architected framework. So let's then have a look at the pillars, the common pillars. We have security, reliability, performance efficiency, cost optimization, operational excellence, and the latest pillar, which is sustainability. Okay, so those are the 6 pillars of the well-architected framework, and each pillar got a set of governing principles that needs to be implemented at each section of your workload. So we are going to have a look at this, we call them the designing principle under these pillars, and just have a discussion around that, seeing how we are going to get our workloads on AWS in the best way possible. Now, remember, this is a cloud practitioner bootcamp. I'm not going into technical details so that I don't confuse the audience. We are here just to, on a high level, understand what these pillars are, what are the designing principles, so that at the end of your preparation, at least you understand the pillars in details. But if you really want to go deeply into each and every pillar, I recommend you to have a look at AWS documentation. There's labs under these pillars if you really want to understand it deeper. But today we're just going to, on a high level, mention the pillars and also the designing principle for the sake of the cloud practitioner exam. And also, one disclaimer is the slide that I'm using there for AWS, probably you have seen them on the internet. So yeah, just bear that in mind. They're not my slides, they're the AWS official slides. So let's first have a look at the first pillar, which is security. Now, Okay, before we get into security, we have mentioned the designing principles, and we have two. We have the general designing principles, and we have pillar-specific designing principles. So before we get into the pillars, let's just have a look at the general designing principle and see what it talks about. So as I mentioned, designing principle, it refers to the fundamental concepts and guidelines that underlie the designing and implementation of workload on AWS. So these principles help organization make informed decisions about architectures and ensure that their workloads align with AWS best practices. The next slide is talking about the general principles, general designing principles, which cuts across all the 6 pillars. And the first one is stop guessing your capacity needs. So what this designing principle means, let's take, for instance, you have an application that needs to be hosted on AWS cloud. So you first need to understand what sort of services are we going to use that supports your application. For instance, if it's a WordPress site, you'll definitely know that we can go with an EC2 instance, but not just any type of EC2 instance. Because remember, in cloud, you use the pay-as-you-go model. So you need to be aware of the details of the metrics that you're going to use. Let's say this WordPress is going to serve 100 people. So what sort of family of the EC2 instance are you going to use? So these are just questions that are around the capacity needed. And the main information here is you need to be aware of the virtual CPUs that you're going to use. You need to be aware of the memory of your application that you're going to use. And also you need to be aware of the storage that you're going to allocate for any application, for any workload that you're going to host. Now, for the sake of end users and the experience, you need to choose align these resources in a way that the end users have a seamless experience. We don't want to get to a site where it's lagging due to the use of low memory, or we don't want to get on your side. You don't want to have your site over provisioned, because over provisioning means you're going to incur a lot of monthly costs while running your service. The reason why you will want to migrate to cloud one is maybe to cater for cost at a lower cost and all that, because as we'll learn later on, there's something called economy of scale, meaning if you do right sizing of your application, if you do give the necessary or the required capacity without under provisioning or over provisioning of these resources, you're definitely going to enjoy your stay on cloud. But if you over provision, you are definitely going to incur a lot of monthly costs. How about under provisioning? It will be a problem with the end users. They're not going to have a great experience. So the first designing principle is you need to stop. You don't have to guess your capacity, but you need to have a discussion around it, understand what what are the requirements of this application. And the best thing about AWS, the best thing about cloud is you can start small and gauge how the users, how your application is performing, and as time goes by you can right size. Okay, so that is stop guessing your capacity needs. Then the second one is test systems at production scale. Let's say, for instance, you want to host an e-commerce platform. You're not just going to, wake up one day and decide to go, maybe you have everything, you have your application ready. The only part that is remaining is hosting it. You're not just going to host it directly to production. You need to do some sort of testing, understand if, so that's why on a high level, it is recommended to always have two environments, to have a production environment, but most importantly, to have a testing environment. You test with the testing environment, and when you are okay with the application, it's when you can roll to the production environment, so that at the end, you don't experience challenges with your application, with your workload that you want to host on cloud. Then the next designing principle is automate to make architectural experimentation easier. I know all of you definitely know Netflix. And one thing about Netflix is they are purely on cloud. Now, imagine these guys, if they want to do changes in the environment, are they going to, log into the management console and have a look at each and every service that they are using? Probably the answer is no. There's some sort of automation in a sense that we do have scripts that you can edit without necessarily going to your management console. So this principle talks around, using these tools such as CloudFormation, Terraform, Ansible to do your automation, so that whenever you want to push any changes, you don't have necessarily to log into your AWS management console using your graphical user interface, instead of just having a script, and by a click of a button, the changes have been deployed. So you need to think of automating, then allow for evolutionary architectures. Now, one thing that we are all aware of is definitely change is inevitable. And when it comes to technology, technology is changing at a very fast rate. Definitely, we need to cope up with these changes. And this involves, going with the latest technologies. Right now, we are talking of AI and machine learning and all that. Now, let's have a look at the history of architectures. First, using the traditional on-prem, a lot of workloads operate on a monolithic architecture. A monolithic architecture means that the front-end, back-end, and database are all sitting on one underlying physical server. Later on, when cloud was introduced, we had a concept to do with two-tier architecture. Now, the application, the front end and back end, used one, not physical, but virtual server, while the data layer was on another server. So this brought about the concept of decoupling. Now, later on, three-tier architecture was introduced, whereby the front end was on a separate virtual server, back end on a separate virtual server, and the data on different server. So this definitely got major advantages of it, be it separation of concern. If the front end is down, at least we can still operate with the application. The backend will still be up and running, and the database. So, and also we can scale independently when it comes to these decoupled architectures. Right now, we are talking of microservices, leveraging the use of Kubernetes, Docker, ECS, and EKS to have workloads running in parallel. So this is just a bit of how the architectures have evolved, and you as the end user, you need to go with this change in technology. Right now, you need to have an application that can support microservices. And the best thing is that even though at this point you have maybe an application that is still monolith, you can do what we call refactoring, so that we can refactor your code to fit on the latest and current technology. So that is just also another designing principle that you should take into consideration. Then we have build data-driven architectures. This just talks around, using your data to predict what sort of architectures, what sort of services to use next. Okay, then finally improve through game days. Game days, it's more of testing your application and finding out new ways of improving your workload, of improving your application while using cloud. So these are just the general designing principle. And next, let's now delve into each pillar and understand what are the designing principles under each pillar. And the first one we're going to have a look at is security. So the pillar of security focuses on protecting information and systems. So here, key topics include things to do with confidentiality, integrity of data, how you're going to manage your user permission, and establishing control to detect security issues. Maybe there's a breach, you need to understand how that has occurred. So that is designing, that is one of the most important pillars of the well-architected framework, security. And under this, we have also designing principles such as one, you need to apply security at all layers. Very important. Let's take, for instance, an application, just a simple application. First, there's the code. Next, there's the infrastructure. Then there's the network, and there's the end users. So you need to apply security at all these layers. At the code level, you need to have security best practices while coming up with your code. At the infrastructure level, you need to implement security services that are going to protect your application. Then at the user level, you need to have services such as identity and access management to give necessary permission to users. You don't want all users to have equal permission. Then definitely at the network layer, you need to have your application in some sort of a cloud inside a cloud. So in this case, you're talking about VPC. VPC is just a private cloud inside a public cloud. We'll have a look around that. Then enable traceability, also important. Let's say, for instance, there's an issue with the application. How are you going to know what took place? You need to understand where the breach happened and who was responsible for that. So through the use of services such as AWS, CloudTrail, and Config, you can have this traceability. Then you need to implement a principle of least privilege, as mentioned. You're not going to give access to each and every, give the same access to each and every person who is going to access your environment. If it's the developer, you need to have, the necessary permission that applies only to development. If it's an administrator, you can give him maybe access that will help him in implementation of his administration job. So principle of least privilege just talks around, giving just right access to this, your end users, to these people who are going to access your account, your cloud account. Then focus on securing your system. Definitely, you need to implement AWS services that will enhance security of your system, such as the likes of GuardDuty, the likes of WAF, if it's on application level, and all that. Then, of course, automation is very key. Automation, it's something that will definitely apply across all these pillars, because if it's the security best practices, let's take, for instance, you need to do patching of your virtual servers. You need to have a way of automating this, and so that it eliminates the issue of human error, and also having timely updates of this patching, for instance. So that is the first principle, security. And the next slide, you're just going to see what are the services that can help us enhance security when it comes to having our workloads on AWS cloud. So here we go. Now we have areas and key services. We'll start with identity and access management. And under this, the main service that you're going to use in terms of securing our users, in terms of giving just enough access to our users, in terms of implementing the principle of least privilege is AWS IAM. Definitely at this point, you understand what AWS IAM is. This is just an identity and access management tool that can enable you to give access to your users. We can leverage the use of IAM groups to give access to a large amount of people. We have roles, AWS IAM roles. Maybe if you want a service to access another service, for instance, an EC2 instance to access secrets manager. Maybe there's some parameters that you're storing in the secrets manager, and you need this EC2 instance to have a look at that. You will enable roles. So at identity and access management, AWS IAM is key, and also we have MFA token. This is just two layer of security, having one layer, let's say the first layer a password, and the second layer maybe using an the MFA token to take your fingerprints and all that. Then the second area is detective controls, and here it's talking about traceability. So we are going to use AWS CloudTrail to understand who and what people are, the trails of end users that are accessing your workload, your account, so that in case of anything, we'll understand what happened and who was responsible for that. We have AWS config and Amazon CloudWatch for monitoring. We can use CloudWatch to you will define some metrics for CloudWatch. Then this service will enable you to monitor, especially your performance, the performance of your workloads in cloud. Then you have infrastructure protection, and here it's where Amazon Virtual Private Cloud, the VPC, comes in handy. Remember, cloud, it's a public resource. So anyone with an internet connection can get to it. But if you have a sensitive application that you don't want anyone to access it, you need to put it in a VPC. A VPC, put it in subnets, private subnets, so that only the right people and the right resources can have access to your application. This will prevent issues to do with breaching and maybe your system being hacked. Then we have data protection. The services are Elastic Load Balancing, Amazon EBS, S3, RDS, and KMS. So make sure your volumes are encrypted. Make sure your RDS got, the necessary login credential, username, and password. Make sure you are storing, you're using KMS to encrypt your, your S3 buckets and all that. Now, maybe you're wondering where Elastic Load Balancer comes in. Now, remember we did mention of Amazon VPC. And let's take, for instance, you have an application. This application is running on an EC2 instance, and your EC2 instance is in a private subnet. So if it's in a private subnet, it means it has a private IP address. So it's something that is not accessible via the internet. So what we can do is we can set rules for integration of the load balancer and this EC2 in the private subnet. We'll have the load balancer in a public subnet, redirecting traffic to the EC2 instance in the private subnet, so that the end users, what they will be interacting with is the IP address of the Elastic Load Balancer, but not your application on the EC2 instance directly. So be it if it's a bad person, they will maybe access the load balancer, but they won't reach your EC2 instance. So that's why our load balancer comes in handy. Then incident response, we have IAM again, so that we know the users, the necessary users. Then AWS CloudFormation, again, for automation. So that is it for the security pillar. And next, we're going to have a look at the second pillar, which is reliability. So first, definitely we are going to have a look at the design principles for reliability, and we'll also just have a discussion around the services that will enable your workload to be reliable. Now, when you talk about reliability, this is a pillar of the well-architected framework which focuses on how your workload is performing. Is it performing the function it was intended to? And how, in case of maybe a disaster, how is it going to recover from failures to meet demands? Because, as end users, imagine you're using Netflix and all of a sudden you're watching your movie, all of a sudden it goes 404, page not found. We don't want to experience such a thing. We want at the back end of it all, Netflix to be able to predict that such a thing is going to happen and recover without any downtime, without any for errors. So this is the pillar that talks around that. And these are just the designing principles that are under this pillar. And just a minute. One, we have test recovery procedures. So test recovery procedures, it's talking about testing your strategies. Test recovery procedure. Let's take for instance, you have an application running in Africa, Cape Town region, and you have defined a backup or recovery procedure in, let's say, island region. So you're not going to wait for a disaster to happen before you fail over to the island region. You need to, once in a while, perform testing so that you can see if the other region will be capable of, serving your application and continuing with the necessary the necessary procedure, the necessary work it was intended to, if something bad or maybe if a disaster happened to your primary region. So you need definitely to have these testing recovery procedures so that you'll be ready in case of a disaster. Then we have automatically recover from failure. And this also talks around automation. I told you automation is going to be very handy in this case. So we need to be monitoring your workload for key performance indicators. You can, you need to have a system, you need to automate your workload and have triggers that can help in case of anything bad happening to your, as I mentioned, your primary region. So you need to have these triggers automatically when maybe there's a breach, so that we don't have manual procedures when anything bad happens in this case. So for instance, when Netflix is down, we don't need people to get into the account and try to fail over to the other region. We need to have a way of automating this so that there's a seamless experience to the end users. Then definitely scale horizontally to increase aggregate system availability. So horizontal scaling, we have two types of scaling. We have the vertical scaling and horizontal scaling. So horizontal scaling, it will definitely leverage the use of auto scaling groups, so that maybe if your system is maybe let's say for instance an EC2 instance, maybe there's a surge of users. There is too much traffic being experienced on this one EC2 instance. So autoscaling has the capability of spinning up other instances to serve this extra traffic. So yeah, you need to put that in mind. Make sure you have autoscaling groups in place. You have defined the minimum, maximum, and required threshold and all that. Then again, stop guessing capacity. We talked about this. You need to allocate enough capacity to your application. Then Finally, we have manage change in automation. Again, automation comes in handy. Make sure you're using, CI/CD tools. You're using scripting tools to do your automation. Very, very important. So next, we're going to have a look at the necessary AWS services that are key when it comes to reliability. So areas we have foundation, we have change management, and we have failure management. So on the foundation level, definitely you're going to use AWS IAM for user identity and all that, and then Amazon VPC for having your application secure, but at the same time, making sure that this VPC got in VPC. Remember, we have what you call availability zones, right? So, for instance, Cape Town, Africa Cape Town region has 3 availability zones. So inside this VPC, you need to maybe use what you call to enable high availability. In case one availability zone is down, the next availability zone should take over. So you should think of having a highly available workload by implementing 2 or more availability zones in a region using VPCs. Then change management, we have CloudTrail and AWS config. Probably the work of these services. Then failure management. When it comes to automation, the native infrastructure as code service to use is AWS CloudFormation. But away from that, we have Terraform, which is also equally important. But also we can leverage the use of Elastic Disaster Recovery. This is a service that can enable you to recover whenever a disaster hits a region. So those are just a few AWS services that are under reliability. So next, you're going to our third pillar, which is performance efficiency. So performance efficiency, this pillar, it talks about the ability to use computing resources effectively to meet system requirements and to maintain the efficiency as demand changes and technology evolve. So I'm reading from the AWS documentation, and that's what they define performance efficiency as. It includes the ability to use computing resources effectively to meet system requirements and to maintain the efficiency as demand changes and technology evolve. As I mentioned, technology is shifting, it's changing at a very fast rate. We need to have a workload that is in line with this. It's flexible in a way that you can easily adapt new and modern technology without experiencing any issues to do with the performance of your workload. So just a few designing principles under this pillar are: 1, democratize advanced technologies. 2, we have go global in minutes. 3, we have use serverless architectures, experiment more often, and mechanical sympathy. So democratize advanced technology. This designing principle, it's just informing us that we need to be aware of new technologies that arise. Right now, you're talking of AI and machine learning. So when you're thinking of designing an application, designing a workload, you need to put that in mind. Where can we use AI and machine learning to make our application, to perform efficiently? So you need to be aware of this technology, and you need to design in a way that your application supports these technologies. Then next, we are talking about go global in minutes. So this is simply telling us that if it's an application, let's take, for instance, again, you're using maybe the Cape Town region, and you need to use other services that can enable global outreach. For instance, we can use AWS CloudFront, the content delivery network, to make sure that your application is accessible in the entire globe, with low latency. So we can leverage the use of SaaS services, but also you can just you need to have some sort of disaster recovery in another region. So whenever your primary region is down, we can definitely fail over to the other region. Then at this point, you also need to incorporate the use of the serverless services because with these services, they are by default highly available and can enhance the performance of your application. So when you're designing your solutions, you need to cater that in mind, using services that can enable users around the globe to have access to your application with the lowest latency possible. Then we have I mentioned of using serverless architectures. So the serverless architectures, definitely they will remove the need for you to, run and maintain, the physical servers. There will be no need for you to do patching, no need for you to, worry about the infrastructure, as AWS is going to do the patching, the performance, security, and all that for you. On your side, you're just going to focus on your application and seeing how you can improve it. So I'm talking of, using services such as Lambda instead of EC2 instances and all that. Maybe also just using AWS managed services rather. For example, RDS, instead of you having your own MySQL database, which means you need to, be worried about the underlying infrastructure and all that, you can leverage the use of RDS as AWS will manage your underlying infrastructure for you. Your main concern will be inside your database, not the infrastructure that is hosting it. Then experiment more often. Definitely, this is important. So through automation resources, you can quickly carry out, testing, maybe using different instance types, storage, and configuration, so that you understand what best serves your application interest. So you need to experiment more often to make sure that your workload is effective. Is effective. Then finally, we have consider mechanical sympathy. So mechanical sympathy is just a way of using the right service to serve your application. Maybe your application is just considering the use of services such as maybe for instance, you just have a static website. There will be no need for you to put that in an EC2 instance. You can easily leverage the use of S3 so that you can, benefit, one, from low cost, but two, you're just using the right resource, the right service for your application. This will be handy when it comes to cost optimization. So while you're designing your architecture, while you're designing your workload, you need to keep that in mind under this pillar. So next, we are going to have a look at the services that will end, that are key when it comes to performance efficiency areas. We have selection, we have review, we have monitoring, and trade-off. So selection, we talked about, okay, we have Amazon EBS, we have auto-scaling for, scalability, we have Amazon S3, we have maybe the use of Amazon Glacier, maybe you are storing files that you want to access them after 1 year. So you use the right, S3 class, for instance, Amazon Glacier to do that. Then I mentioned of, the native AWS services such as RDS instead of maybe having your database on an EC2 instance. Then the likes of Amazon DynamoDB, that's just also a native AWS service, which is fully managed by AWS. So this is on selection. Make sure you select the right tool the right service for your application. As I mentioned, don't go on hosting a static website on an EC2 instance and there's Amazon S3. Then on review, we definitely review. It's just talking of maybe the use of scripting tools. Then maybe, for instance, if you have anything, maybe if you want to do the testing and all that, we need to save time and you need to use automation tools so that if it changes, they are up and running within few seconds. So we can use AWS CloudFormation. Then AWS blog. This is just informing you that you need to keep reading. Look at AWS blogs. Look at ways of enhancing your workload so that you're using the latest technology and all that. Then for monitoring, we have definitely CloudWatch, the main monitoring service. Then trade-off, we have Amazon CloudFront, Amazon Elastic Cache, and AWS Snowball. CloudFront is for content delivery network. Amazon Elastic Cache, this is just a caching service that can be used in conjunction with a database such as RDS. So maybe if you have a lot of users writing to your database, they can go through the Elastic Cache. It caches the content so that there's some sort of an offset when it comes to your database. Then Snow Mobile, probably you understand its work. So I'm not going to get into deep details of that. Then next, we are going to have a look at cost optimization. Now, cost optimization here, this is the pillar that just focuses on avoiding unnecessary costs. So key topics here include understanding spending over time and controlling funding allocation, selecting resources of the right type and quantity, and scaling to meet business needs without overspending. So under cost optimization, one key benefit of using cloud is that it's a pay-as-you-go model. It means compared to the traditional on-premise environment where you have to purchase a physical server, in cloud, there's issues to do with right sizing. You can start small, look at how your application is performing, then right size it later on, without the need of purchasing any physical server again. If it's on premise, you want right size rather. If you purchased a server, let's say with 32 CPUs, 64 GB of RAM, 1 TB of storage, and maybe your application requires just a minimum, metrics, you're not going to reduce that server. You're going to be left with that server. But at least in cloud, you can have an option of, downsizing or right sizing just in line with your application needs. So that is one advantage that is under cost optimization when it comes to leveraging your cloud technology. So the designing principles here are adopt a consumption model, benefit from economy of scale, stop spending money on data center operations, analyze and attribute expenditure, and then use managed services to reduce cost of ownership. One key thing that you need to understand is a lot of managed services are cheaper compared to services that require some sort of end user management. For instance, AWS Fargate is way, way cheaper than EC2 instance. So AWS is just encouraging us to use these managed services. One is, they're reducing on operational overhead, but two, you're also going to cut down on cost. So these are just the designing principles under this pillar. So maybe let's just go through it again to understand deep into details. Let's start with adopt a consumption model. And here it's saying that pay only for computing resources that you require and increase or decrease usage depending on business requirements, not by using elaborate forecasting. For example, development and test environments are typically only used for, let's say, 8 hours a day during the week. you can stop these resources when they are not in use for a potential cost saving. So that is around just adopting a consumption model, then benefit from economy of scale. So this, remember, so how it works is these data centers, of course, at the bottom layer, we have the physical server. Then there's a virtualization being done, and that's why we have the virtual server. So you can have your virtual server, you can have, we can have, let's say, 6 virtual servers that are on one physical server. So this means that, imagine uh, you're going to save cost when you use AWS, because you are 6 of you are operating on one physical server, rather than you having to purchase your own server, your own physical server. So that's economy of scale. Just just the main the fact that we have virtualized environment, it means definitely AWS will have a look at this, the cost of your, the cost of running this physical server, and then it can be distributed to the 6 of you. So you're just going to pay a portion of using that physical server, rather than, you having to pay the full portion of using that physical server. But not to confuse you, I know earlier on you have definitely talked of, having what is it? There's the physical instance. There's there's a shared host. There's a shared instance and all that. So not to confuse you, but yeah, that's just one of key benefit, or one of the principle of the cost optimization, which is a benefit from economy of scale. Then stop spending money on data center operations. Definitely, when you are planning to migrate to cloud, there's no need of you having a data center, unless maybe you want to do disaster recovery and all other procedures. But for instance, if you don't require such, you will only have your workload deployed on cloud, and so there's no infrastructure, there's no physical infrastructure to maintain. Then analyze and attribute expenditures. So here the documentation is saying the cloud makes it easy to accurately identify the usage and cost of systems, which then allows transparency attribution of IT costs to individual workloads owners. This helps measure return on investment, ROE, and gives workload owners the opportunity to optimize their resources and reduce cost. So next, let's have a look at the services that are under this cost optimization. In the areas, we have cost-effective resources. We have matched supply and demand, expenditure awareness, and optimizing over time. Cost-effective solutions are resources, rather. Key services, we have AWS Trusted Advisor, and then for instance, we have reserved instance. So the concept of reserved instance is you're going to have a larger discount as compared to using on-demand instances. Let's say, for instance, you have an application that is going to run continuously for 1 year. Once you've known this information, you can opt to go with a reserved instance. So you're going to commit for the full year. Maybe there's all upfront or no upfront. You commit for the entire year, which will give you, definitely will, as compared to your on-demand cost per month, it will come at a lower rate, which will definitely save cost on your side. Then AWS Trusted Advisor, it will just give you recommendation of maybe rate sizing, so that you do cost optimization. Then we also have another service called EC2 Optimizer. So what an EC2 Optimizer does is it checks your workload running on the EC2 instance. It looks at the CPUs, the RAM, and the storage, and it will advise you if your instance is under provisioned or over provisioned. Then it will give you a recommendation of the right instance to use, and definitely that will help in cost optimization. Then definitely auto-scaling group, you can leverage auto-scaling group, match your supply and demand. And then for expenditure awareness, we have Amazon CloudWatch. It will, monitor your environment and give you insights through SNS. SNS, this is just a notification service that can get triggered in case of any metrics being, any threshold being exceeded. So, of course, we do have other services such as, AWS budget, cost explorers, and all that. And then definitely you will need to keep learning through AWS blogs and other relevant information. So that was cost optimization. Then we go to the fifth pillar, which is operational excellency. Operational excellence, this is just a pillar that focuses on running and monitoring system and continuously improving processes and procedures. Here, key topics will include automation, of course, responding to effects and defining standards to manage daily operation. So when it comes to operational excellence, you need to design your solution in such a way that it will have a reduced, overhead procedures. And the best way of designing a solution is through, automating it using infrastructure as code to build the environment, and also using CI/CD services to automate your environment so that, it will eliminate the need of you physically going to your management console using graphical user interface, the GUI, to go and, deploy, to run your services that will support your application. So automation is key when it comes to this pillar of the well-architected framework. Then just to mention the designing principles under this pillar, we have align operations processes to business objectives, perform operations with code, make regular small incremental changes, test for responses of unexpected events, learn from operational events and failures, and then keep operational procedures current. So I won't go into further details explaining those designing principle, but just if we have a look at the services that can enable us in this pillar, we have AWS developer tools using CloudFormation, config, the likes of code build, code deploy, and code commit for CI/CD. Then what else? AWS CloudFormation or Terraform for scripting. Then in terms of responses, of course, CloudTrail for trails, CloudWatch for monitoring. Then just maybe using serverless services such as Lambda for compute. So those are the 5 major pillars of the well-architected framework. But now the last pillar, probably you are aware of it, which is a bit, it's still new, it's sustainability. And sustainability is around how are you managing your environment. Now remember, cloud is just a data center located far away from your location. In this data center, we do have power, we do have generators, and definitely they are emitting some gases that are, harmful to the environment. So the sustainability pillar, it's just focusing on, cutting down on, the usage of services that can lead to pollution of the environment and all that. So that is still a new pillar, but you on your side just have a look at it, understand it into details, because if you're preparing to do the examination, you definitely have it. You definitely see it in the exams. So those are the pillars of the well-architected framework that I had prepared to tackle on. Then the last section was on ecosystem. And now on my case, when it comes to ecosystem, what I've done is I just want us to have a look. Let me just stop sharing first, then I share again. So I want us to I've created a scenario for us. We have a look at what company XYZ wants. Then at the end, you're going to build an architecture diagram that is in line with the 6 pillars of the well-architected framework. So allow me to share my screen again. Just a moment. Sharing, and you should see it on your side. Let's see. So this is the scenario that I came up with. Can you guys see my screen?
Yes, Juma, the screen is visible.
Nice, thank you. So the scenario is XYZ corporations got a 3-tier application that needs to be migrated to cloud, right? So it has a 3-tier application on-premise data center. The application experiences occasional performance issues during peak usage, and scaling resources is a time-consuming process. They also face challenges in ensuring high availability and disaster recovery. So what are the goals? One is scalability, 2 is reliability, cost optimization. Then, of course, the well-architected framework pillar consideration is operational excellency. So they want maybe automation to be incorporated in. We have, perform operation as code, maybe the use of AWS CloudFormation or Terraform. Then, of course, reliability is also key. And then performance efficiency and all that. So they are saying we use serverless architecture implementation. Consider serverless option for components that can benefit from auto-scaling, such as AWS Lambda, CloudFront for content delivery network. Then cost optimization, of course, you're going to implement our solution in a way that it's not going to consume a lot. So yeah, those are just on a high level the requirements that we need to keep in mind. And now here is what I've designed to, in line with what is required. So first, we need to understand XYZ, it's a 3-tier. They want a solution that is a 3-tier, right? So the web server is different from the application layer, from the data layer. So as you can see, we have the web server in an EC2 instance, we have the application server in an EC2 instance, and we have the data layer, which is the database running on RDS MySQL. So I want us to have a discussion around this architecture and see if it really has it's built according to the 6 pillars of the well-architected framework. Now, let's start with the first pillar that we did mention, and it's security. So for security, or maybe let me just explain on a high level, what is happening here. So we have end users, right? And these end users, they are going to access our application. First, they need a DNS. In our case, you're going to use Route 53 for our DNS. So maybe our application is xyz.com. That is the entry that you're going to put in our Route 53. Now, once these users have hit the DNS, the next point that they are going to access is our CloudFront. Remember, CloudFront is a content delivery network that enable users to, to have access globally. And one thing about CloudFront, it's also a caching mechanism. Let's say this user wants to access some information in the database. If it's the first time, the user has to go all the way to our database. But what happens is whatever information will be stored locally on the CloudFront, so that the next user, if they want access to the same information, instead of going again to the database, they will just find the information at the CloudFront point, which of course will reduce the latency. Then we have our S3 to just store static content such as images and all that. WAF is going to protect our CloudFront, is going to protect all the traffic that is getting into our, application. It's going to scan it for, malicious activities and block, IP addresses that we don't need. Then Our system is in Europe Island region, but it's across two availability zones, availability zone A and availability zone B. So these users, when they want access, maybe they want to access the front end, what happens is they'll hit the IP address of the application load balancer. Then application load balancer is going to, redirect traffic to the web server. But now, the application load balancer is the only service that is going to communicate with the web server, not the users directly. So the users are only seeing the application load balancer, then application load balancer is accessing the web server. So it means when it comes to security, our application in a way it's secure because our users are not having direct access to our application as it's in a private subnet. So they can't, if it's a private IP address, you can't have access of it over the internet. But our application load balancer will be in a public subnet for our end users to access it. Then, so I was mentioning about the two availability zone for, high availability. We have availability zone A, availability zone B. Now, for instance, this availability zone here goes down. Let's say the zone is down. We still have availability zone B to load and to host our application, and through application load balancer we are still able to access it. Okay, so that is a high availability in place. Then we have NAT gateway. If our applications want to access the internet, they will have to use the NAT gateway. They can't access the internet directly because that is insecure. So that is it, web server, application server, and master. So we've discussed 6 pillars of the well-architected framework, right? So let's have a look at each pillar. We started with security. The first point of our application being secure is having our web application firewall. It's going to protect our application from malicious activities. The next security practice that we did in this implementation is hosting our application in private subnets, right? Meaning users don't have direct access to this application. They only have access to our LB. So that is also a point. Then the next security measure is putting our application in a virtual private cloud so that, not everyone got access to it, but only the required people can access it. So that is another security-based practice. Then, of course, additionally, we will incorporate services such as guard duty, AWS inspector, to make sure that our system is secure. So that is in line with the security pillar. Maybe anything that you notice which is under security that I've left it out, just have a look. Let me do this. Have a look at this architecture diagram and think of maybe any service that is being implemented that enhances security of our application. So I'll just give you a few seconds to have a look at it, and maybe if you have anything to answer, you can kindly unmute and mention. Okay, I've seen one. Now we're using EC2 Instance Connect. Why? Because this is a new service. It's a service that is equivalent to a Bastion server, a Bastion host. So maybe before explaining it, let's first understand what a Bastion host is, right? So sorry about that. Let me just duplicate this and let's label this our Bastion server. Now remember, our application is in private subnets. What if our administrators or maybe systems administrator want to have access to this, have access to maybe the application server or the database without, using our DNS? Maybe they want to close a certain port or open a port. How will they access our environment? That one of the main case that we use when it comes to having that access is leveraging a bastion host. So a bastion host will be in a public subnet, then the administrator can SSH into it, then can SSH into the web server or the application server. Then through the application server, they can have access to the database. So that is a bastion server. So EC2 Instance Connect eliminates the needs of having this server. You just connect directly to your application server, maybe if you want to have access to database. So I believe that's also a secure way of having access to our backend and database. So that is the last point of security that I'm seeing, and I believe we have exhausted all of that. The next pillar will be around operational excellence. I believe so. And now that we did mention that the main thing here is automation, I don't see, we've not incorporated any CI/CD tools, but Terraform, the use of, we can use Terraform to, have our infrastructure up and running, which is a section of, our operation excellence. It means that, maybe in terms of having our application app, it will take few seconds instead of manually doing it inside our console. So we have Terraform, but maybe to improve on our architecture diagram, we can leverage the use of our CI/CD tools. We can use our code build, code deploy, and code commit to have our automation process, so that the developers, if developers have any changes to make to application, they can use the CI/CD tools, which will automatically, update the changes into our infrastructure. So that is it. Then, in terms of cost optimization, we won't see that in place because we've not costed for these services. But now maybe what we can do under that is making sure that we are going to use the list, services available. If it's the EC2 instance, for instance, we can use maybe a T2.small or a T3.micro to cut down on costs. Because remember, we have an issue of auto-scaling group. So whenever there's too much traffic, this auto-scaling group can automatically scale our application to meet that demand. So yeah, that in cost, we won't see this unless we have deployed it fully, but just bear in mind that we can start small and right size as time goes by. Then in terms of in terms of reliability, one is that we have two availability zones. So when this zone is down, we can still have access to the other zone. But now also, I believe we can use a disaster recovery solution to have the same infrastructure being deployed in another region, so that if this region is down, what happens is Route 53 will automatically fail over to the other region. So maybe to illustrate that, let's just duplicate this environment and see that in place. So we're just going to duplicate the environment and move it to, that will take time, move it to this other side. Then, as I mentioned, we're just going to, so let's say this is Africa region. So it means that maybe, okay, God forbid, but maybe this region is bombed, meaning the availability zones are down, the 3 availability zones are down. What happens? Remember, Route 53, it's not a regional service, it's a global service. So this can be, this will fail over to this standby region. What am I doing? Yeah, so this Route 53 can fail over to this other region. Sorry about that. Yeah, to this other region, so that users can still continue to have access to our application. So there will be downtime, but there will be downtime, but will be less compared to maybe if we have only our services in this availability zone and it's down, it will take long to have this infrastructure up and running in a new region. But if we have a standby region for this, for instance, here, we can easily fail over to the other region in a minute of seconds or minutes. Yeah, so that is reliability. Then which other layer have we not? Which other pillar have we not mentioned? So you've talked of automation, you've talked of cost optimization, security, reliability. Of course, sustainability, we won't see sustainability in action because we are yet to deploy this environment. So we're not going to have a look at that layer in our environment. Then finally, I think it is, let's see, have we talked of performance efficiency? So, yeah, performance efficiency. One, of course, go global in minutes. We've talked of, having the application deployed in different regions. Then maybe leveraging the use of auto-scaling groups so that in case anything happened to, in case traffic is too much, maybe we start with one EC2 instance. If there's too much traffic, we can automatically scale it across these availability zones to the second EC2 instance, meaning that users will have a seamless experience with the application. Now, I believe that is it on my side. Yeah, it's been amazing talking to you. I've been talking for such a long time. At this point, I will welcome any questions, any concerns, any feedback from the audience. Thank you so much. Over to you, Dan.
Okay, thanks, James. So we can take just a few questions. The following. So Kevin mentioned that. Okay. Okay, yeah, Kevin, maybe you can unmute and just give a bit of clarity on this. But I think what you mentioned is really good. So you mentioned a bit about secret management, like how do we keep, how to keep your DB credentials and things like those. Also, KMS. So I think he was referring to the security aspect.
Security. Yeah. Thank you so much, Kevin, for that. Yeah, I totally agree. Secrets Manager, KMS for encryption, AWS config for config files. Then I am for access. For high-stake workloads, e.g. those in fintech or health, you can use Amazon Mercy and S3 lifecycle policies. Thank you for that, Kevin.
Okay. So I think we can just take one or two questions. So yeah, let me see. Yeah. So,
may I go?
Yes, Isaac, you can go.
Hi, James. How are you doing, man?
I'm good. How about you?
I'm doing great. Great presentation over there. That was so insightful. I think I'm impressed. So mine is not really related to the 6 pillars per se, but is more of something that you've experienced. So according to you, what are some of the common bad practices that you find newbies doing while they're getting into the industry that you might shine some light on and think that could be something good?
Okay. Isaac, thank you so much for that question. Yeah, what are some of the bad practices that we see, users or our clients using? One is having, their application in a public subnet. So a lot of end users, they put their application in a public subnet, and then they don't leverage the use of application load balancers, but rather end users can access the instance or the application directly from the internet. Because remember, when we use a public subnet, it means that IP address can be accessed by the internet. So in case there's a bad actor, your application is vulnerable to being breached because there's no sort of, gates before getting to your application, if you understand what I mean. So that is one of it. A lot of applications are being hosted in public subnets. The best and the recommended way is having the application in a private subnet and using NAT gateway and application load balancer, to access this application. Then the next thing is to do with having, of course, on their side, this can do with maybe cost, but it's not recommended to have your application hosted in one availability zone because availability zone can go down anytime. Maybe the zone can go down anytime, and if it's a sensitive workload, on your side it will be losses on your side, right? So that is the second one. People do trade off between cost and having an application that is highly available, but the best thing here is you can do is you can now take, for instance, you have an application that you want to host it in an EC2 instance with, let's say, 4 vCPUs and 16 GB of memory. Instead of having that on a single EC2 instance in one availability zone, why can't you cut down, have two EC2 instances with, maybe if it's 4 vCPUs, we cut them down to 2 vCPUs and 8 GB of memory. We have an auto-scaling group. Then one EC2 instance is in one availability zone. The other is in the second one. So at the end, you still have your application with 16 vCPUs. 8 vCPUs and 16 Gs of memory, but it's highly available because what we've done is we've cut down and used two EC2 instances, two smaller EC2 instances as compared to one. At the end of the day, you're going to use the same cost, but the second part, it's more secure compared to the first part. So the second part, it's highly available, meaning whatever happens to your maybe zone, you can still get information. But the second one, it's single AZ, so it's not highly available. And then, of course, remember the cloud, especially AWS, got a lot of services. So the other thing that we usually see is when it comes to application servers, a lot of customers end up forgetting a web application firewall. Very crucial, a web application firewall. So there's no firewall to protect your environment, meaning anyone can breach your environment. Okay, so those are just a few of the common cases that we've seen so far.
Thank you so much for the insight.
Okay.
Oh, sure. Thank you.
Okay. So James, thank you. Thank you very much for the session. I believe we have learned a lot and basically see how we can leverage on some of the things that we have learned in the other sessions as well. So thank you. So I think we can move to the other part of the session where we are going to do our usual Kahoot to basically see if we've grasped what we've learned here and Yeah, so let me just give me a few minutes. So copy the link. Okay, let me share the link in the chat. Um, okay. So I don't even remember to share. Yes, yes, Cynthia, yeah, of course. So I see Cloud Niger is already there. Same for Eric. Yeah. So let me share the screen. Share screen. Yeah. You can tell me when the screen is visible. Cynthia, is the screen visible?
Yeah, we can see your screen.
Okay. So I see Eric and Cloud Ninja, sorry, Cloud Ninja. So let's just take few minutes, 1 or 2, just to see if others can join as well. If none, we can just continue. So today's Kahoot will be all about what we saw today and a few questions from the last 2 sessions that we had, just to have a recap of what we've learned in the past as well. But yeah, I think all which is asked here touches what we've seen, especially today. And yeah, so it will be simple. Okay, I think we can just start. Okay. So I hope my screen is visible and I'm audible as well. Just tell me when this one isn't. So the first question is goes like auto scaling in EC2 and DynamoDB are examples of what? Is it horizontal scaling? Is it vertical scaling? And DynamoDB are example. Okay. So yeah. So auto scaling is an example of horizontal scaling, where we basically add more machines on the machines that we already had. Contrary to vertical scaling, where we basically change the instance that we're using to a bigger one. So yes, a majority got it right. So moving on to the next question. So AWS Trusted Advisor can provide guidance against the 6 well-architected pillars and architectural best practices. Is this true or false? So the answer is false. AWS Trusted. Okay, so this refers to guidance, the guidance part in the well-architected pillars. Yeah, let's proceed with the next one. So question number 3. Which of the following are design principles of performance efficiency? So make frequent. So yeah, what are some of the, so here they are mentioning some of the things which are best design principles for performance efficiency. So they are saying mention, make frequent small reversible changes and anticipate failure. So I believe this is part of the operation efficiency, if I remember well from the session we just had. Second, analyze attribute expenditure, stop spending money on data center operations. So this is as well an operation. Is it operation performance or something like that, I believe, but it's not performance efficiency. Automate security-based practices, best practices that keep away people from data. So this is in regards to security. So the best answer here is to go global in minutes and experiment more often. So yeah, say majority choose number 1. Number 1 would make sense as well, but I believe the last one makes more sense. So let's go to question number 4. Which of the following is not an AWS partner network type? APN network partners, APN training partners, APN service partners, or APN consulting partners? Okay. So I see a majority got this right. So the one which is not an AWS partner network is APN service partners. So go to question number 5. Stopping guessing capacity and managing changes in an automation are design principles of performance efficiency. Is this true or false? So yeah, this is false, since this one is part of the operation excellence part of the well-architected framework principles. So yeah, I also believe James touched a bit on this. So yeah. Question number 6. Which AWS service is the key to operation excellence? Cloud formation, ops work, code deployment, or EC2? Yeah, so this, I see the majority got it right. So it's cloud formation. Since with cloud formation, you can basically automate all your tasks and make the operation side a bit more efficient, if I may say. So yeah. Question number 7, AWS Cost Explorer and AWS Trusted Advisor are services examples of which well-architected framework pillar? Security, cost optimization, operation excellence, or performance efficiency? So yeah, the trusted advisor is part of the cost optimization. since it can basically show you where you're spending more or where you're maybe using more than anticipated, if I may say. So yeah, it's an advisor. Question number 8, implementing security groups, NACOS, KMS, or Cloud Trail reflects which well-architected framework pillar? Reliability, security, performance efficiency, or cost optimization? Yeah, so okay, so this, oops, okay, so we go, I think this question is, so this one, I think it's configured wrongly, because yeah, as the majority answered, so this reflects on the security part of the well-architected framework. So yeah, you got it right. So it's on the security aspect of it. Okay. So you would like to convert an NIS3 file so it can be played on users' devices. So which AWS service can help? Transcribe, Sumerian, Upstream, or Elastic Transcoder? So yeah, you can use the Elastic Transcoder to convert your S3 files so it can be played on users' devices. So yeah, I see a majority also got this right. So question number 10. You would like to access desktop applications through a browser. Which AWS service would you use? Upstream, Workplace, Outposts, or EC2 Instance Connect? So the answer is Upstream. Let's go fast so we can complete this one on time. So which AWS service can be used to test your application across real desktop, browsers and mobile devices? IoT Core, Workspace, Upstream, Device Farm. So which one is it? Go faster. Yeah, I see a majority. No, not actually. So it's Device Farm. Okay. Which AWS service is serverless and lets you connect billions of devices to the AWS cloud? Is it IoT Core? Is it Connect? Is it Elastic Transcoder or Transit Gateway? Okay. I see, yeah, half of the participant got it right. So it's, sorry, it's moving fast. But anyway, 13th question. Cloud Endure disaster recovery centrally automates backup across services while AWS backup quickly and easily recovers servers. Is this true or false? Okay. Yeah, also got this one right for the majority. So the answer is false. Next question. So a hybrid company would like to provision desktops to employees so that they can access both the cloud and the data centers. So how to go about doing this? Can you use Workspace? Will they use site-to-site VPN, upstream, or Sumerian? So yeah, you can use Workspaces. So next question number 15. So a company would like to use their on-premise Microsoft Active Directory to connect to its AWS resources. So how to go about doing this? Can you use the directory service? Can you use Direct Connect? Do we use IAM Identity Center or Cognito? So the answer is directory service. Even the name is there in the service itself. So yeah, without further ado, let's continue to the next question. So Cloud Ninja is on top, Sam, Eric, Shex, then Fat. So question number 16, which AWS service allows you to create temporarily limited privilege credentials for your AWS resources? Is it IAM Identity Center? Is it AWS Directory Services? Is it Security Token Services or Amazon Cognito? Okay. Yeah, so the answer is IAM Identity Center. Question number 17. A company just created a mobile application and wants to add a simple, secure sign up, sign in, access control. So how to go about doing this? Do we use IAM? Do we use Cognito? Do we use the electoral service? Do we use IAM Identity Center? So the answer is Amazon Cognito. So we move. Question number 18. A company would like to centrally manage access to multiple AWS accounts and business applications. So how to go about doing this? Do we use AWS organization? Do we use the electoral service? Do we use Cognito or IAM Identity Center? So yeah, the answer is IAM Identity Center. What? No. So maybe I would have to double check this, but I believe AWS organization.
I think it's AWS organizations.
Yeah. So I think this one was wrong. But yeah, so just like the majority answered, it's AWS organization. So with AWS organization, you basically have the capability to manage multiple accounts and business applications without having each one conflicting with the other one. So yeah, I hope I think all of you got this right, so there won't be any issue with the marks. So the one on top will continue to be on top. So the one on top currently is Cloud Ninja. Okay, so question number 19, which service are free to use in AWS? So which one are they? IAM, VPC, Consolidated Billing, and Elastic Beanstalk? Is it SNS, SQS, IAM, and VPC? Is it Elastic Beanstalk, CloudFormation, Autoscaling, Groups, and Lambda? Or all services have a free tier? So yeah, the first answer is the right one. So with IAM, you basically don't need to pay anything. Same for VPC, same for billing, For the elastic beanstalk, I will just have to confirm. But for the other three, I believe all of them are free. So for the other one, SQS, yes, James.
Yeah, remember Elastic Beanstalk, you pay for underlying infrastructure, but you don't pay for the beanstalk itself.
Okay.
Yeah.
Nice. So yeah, I believe for the other ones, you have to pay. For Lambda, you have to pay. That's the first thing. For SNS and SQS also, you have to pay for the number of. For SQS, the QA, the incoming QL is solely. So the blocker and the producer and consumer thing, you have to pay for incoming traffic. SNS, you have to pay for notifications being sent as well. So yeah, I believe the first answer makes more sense. We move on to question number 20. So let's move fast. CloudFront pricing is the same in every geographical region. Is this true or false? So yeah, the answer is false. I think this one is not for CloudFront only, but the way AWS does pricing, so for different services, we basically don't have the same pricing in all the regions. So I'm not sure if this applies to all services, because for global services, I think the price, although global services, a lot of them are not priced like I am, VPC, and the other ones. But I believe, I'm not quite sure, maybe someone can help me, but I believe for.
Yeah, you're right. Now remember, CloudFront pricing is the same. So here they're just simply asking you, is CloudFront a global or regional service?
Yeah.
So if it was a global service, then the pricing would be the same. But if it's a regional service, definitely a region such as South Africa, it's expensive compared to a region such as Ireland. So you're right.
Yeah, definitely. Okay. Thanks, James. So we continue. Question number 21. Cloud Ninja still on top. When you reserve the larger the upfront payment, the smaller the discount. So is this true or false? Is this true? Is it false? The larger the upfront, the bigger the discount, or is this false? The upfront payment does not matter on discounts. Yeah, definitely. So with AWS, the more you reserve, the more the discount becomes. So if you can reserve for 1 year, you can't compare with someone who is reserving for, let's say, 3 years. So that's why we even have different pricing models, especially for EC2s. So for reserved instances, you basically can commit for 1 year or 3 years. So yeah, as long as higher you go in terms of reservation, I mean in terms of time, also the higher the discount goes. So yeah. Okay. So we move to question number 22. Which of the following is not a pricing factor in S3? So we have data transfer into S3, we have storage classes, we have object sizes and types of requests. Pricing factor. Yep. So I see all of you got this right. So yeah, let's move on to question number 23. So EBA snapshots are added cost in GB per month. Is this true or false? Yeah. So Maybe to give more highlight on this one. So you see, when you take snapshots, you basically get charged for those snapshots. So the more they are, the more you can be charged, if I may say. So you can decide to take, let's say, snapshots every day, or maybe take snapshots once in 3 months or 3 weeks. But basically, for all those snapshots that you're taking in terms of size, you're getting billed for that. So yeah, the answer here is true. Okay, let's move on to the not the last question. So you're learning a non-demand Linux EC2 instance. What timing is applied regarding to billing? Do you pay per minute? Do you pay per second? Do you pay per hour? Or you pay per day? So yeah, here the answer is per second. So for EC2 instances, you basically get billed for on-demand for on-demand EC2 instances, you get billed per second. So if you use that instance for less than second, I believe you get billed. Maybe James, you can help me here. You get billed for that second, or you don't get billed, something like that. But for on-demand instances, you get billed per second. That's the correct answer.
Now,
so let's say you use an EC2 instance for.
Sorry, Dan. Can I just share my? Okay, I'll share after the game is done. But let's just have a discussion around the on-demand pricing. We can just have a look at it directly from the cost calculator.
Yeah, let's go for the last question, then you come to that one. Okay, so we move on to the last question. Cloud Ninja is on top, Sams, Shakes, and Derek, then Fuad. So last question, which RIDS pricing option is the most cost effective if you need capacity for 3 years? Is it on demand? Is it dedicated instance? Is it spot instances or reserved instances? All right, I see all of you got this one right. So yeah, as we mentioned, the more you commit, the more you get. How can I say this? What is the? So your build less the more you commit. So the discount also goes high. So if you're committing for 3 years, you're definitely getting the best pricing option. So yeah. Okay. So yeah. Okay. So yeah, I think yeah, Cloud Ninja got it. Congratulations to Cloud Ninja. So we are ahead of time, but maybe before we close, so James, let me just give you some few minutes to touch on that before we close. Let me just stop sharing my screen. Okay, so yeah, James, I think you can go on. Okay, screen is visible.
Nice. Okay, I just wanted us to have a look at the costing. So when it comes to AWS, there's AWS calculator where you can cost for your services. So like this is an EC2 instance, and so there's a section of putting your CPUs, memory, network performance, be it storage, and all that. But our main focus will be on the payment option. So we have compute savings plan for our one plan that automatically applies to all EC2 target and all that. So there's a discount, 60% discount. There's EC2 instant savings plan, but now our focus will be on demand. So usage type, we see we have hours per day, hours per week and hours per month. So you will be charged based on hours, not seconds.
Oh,
Yeah,
so you're charged per hour, right?
yeah, you're charged per hour.
Okay, yeah, that's where I was actually wondering, because I know there's the pricing where if you use the AC2 instance, let's say for 20 minutes, like how do we get charged based on that? So
For 20 minutes, so that you have, let's say, hours per day. Then you'll put in so we have 24 hours. You'll convert the 20 minutes into, that will be, is it 20 divided by 60? That is a third an hour. So you'll put here at decimal equivalent to a third. Let me just, I have a calculator here. It is 0.33. So for hours, you'll put 0.33. Then it will show you the cost that you'll have.
okay.
So there's hours per day. If it's hours per week, here you will key in maybe how many weeks, but the default one is hours per month, so that here, it's 720 hours. Yeah. So that is it. And then there's also spot instance. You can purchase spot instance. We have standard reserved instance, 1 year, no upfront, or 3 years, all upfront, or convertible reserved instance. That. Yeah, so that is it from my side, Daniel. I just want to say thank you for hosting me. I hope you've learned 1 or 2 things, and yeah, kudos to the work you're doing out there in Rwanda. This is amazing. I'm looking forward to having other great sessions with you guys. Thank you so much, and congratulations to Cloud Ninja.
Okay, James, thank you so much. Happy to have you as well. It's always a pleasure having you here. And I believe we've actually learned a lot of things from these sessions. Since this one basically combines all the things that we have seen in the past. So I believe you guys now have a clear idea of how you can leverage all the things that we have learned, all the services that we have saw, and basically architect anything well, based on what we saw today. And yeah, James, we really appreciate. Happy to have you here as well, and we hope next time when we need you, you will be here. So yeah. So without further ado, I think we are way ahead of time. But anyway, thanks guys thanks for those ones who came. So yeah, have a wonderful night.
You too. Thank you. Bye-bye.
Okay, thank you. Bye.
Bye. Thank you, James.
Thank you, Cynthia. Bye.